dynamic, and even for translation itself, going from a signal which is not the transcription but the actual speech is more challenging. So we've done some work with this data where we're trying to translate from the acoustic input, from basically doing spoken language translation. And in that case, adding visual information is more helpful because you actually have noisy input. When we're doing text translation, the source, the input is pretty good. So you can only help in cases where language is really ambiguous or problematic. But if you're doing translation or any other application from a noisy input signal, which is speech, for example, then other modalities play an even bigger role. So that's the work that I've been doing so far.
Okay, a final question. Anyone else wants to ask a final question? Last final question, gentleman, just here.
So this translation was from English to German, right? Was it tried backward from German to English?
No, it was from English to German, French, or Czech.
Yeah.
And just because that's the data that we have, but no, we haven't applied it.
Because Germans, like when they speak, there's very less emotion, so.
Right.
I was wondering, because I worked there.
Germans in the room might disagree.
Germans, fight your corner. Okay, if that's the final question, I'm going to say thank you this year. Well, apparently now we're going to do kind of some video conferencing, I think. Yeah, so basically from Tom Sobkowski, data scientist at Urban Outfitters. He's going to do a 25-minute presentation on automated fashion product attribution. Got that right? Attribution in the end, which actually fills into something following on from the last presentation. A case study in using custom vision services versus manually developed machine learning models. So kind of see which one came out best.
All right, thank you.
Thank you.
Okay. So good afternoon, everyone. My name is Tom Smowski. I'm a data scientist at Urban Outfitters Incorporated, also known as URBN. So as mentioned, I'm going to be covering an example or experiments that we've had with custom vision services for the purposes of product attribution. So that's labeling some of our product imagery with characteristics of what they are, and I'll give some examples to that. So a brief background on our organization. URBN actually includes several different brands, Urban Outfitters, Free People, Anthropologie, and several others. Of those three, they actually have a very wide array of customers, somewhat independently operating organizations for which the engineering teams and data science teams service all of them. And as such, they also have different imagery and different styles on how they take their images and their products, which is one of the challenges that we are trying to address. The data science organization, somebody this morning discussed the different types of organizations. We are more of the hub framework, where we're a small centralized group that services across the different brands, acts as consultants, tries to find ways of automating and streamlining processes. So the most recent application, the one I'm going to be discussing today, is that product attribution. And most of our time, we are machine learning practitioners in our organization, so we spend our time in Jupyter Notebooks using a lot of the common deep learning libraries and trying to roll our own algorithms, so to speak. But we were interested in this recent rise in these custom vision services that many different companies are offering. So we decided to experiment with them, compare them with some benchmarks, and going to be showing it to you today. So the products that we are trying to attribute, just to give a quick example, would be, say, take a dress. An attribute for that would be the length of the dress, the length of the sleeves, the neckline, the pattern, the color. So there's a lot of different very objective dimensions, but also very subjective dimensions, such as the lifestyle. So is it casual? Is it modern? Is it something for business, for nighttime? Is it bohemian? So those are all different types of things we're trying to capture with these attributes. Most recently, I believe the latest number is around 10 million different photos for our products in the last 2 to 3 years that we have in our database. Today it's very manual. The buyers, merchandisers tag it. The web production team tags it for the customers. It's used for trend analysis, forecasting predictions on how products are going to sell, also for customer navigation. So it has a lot of different purposes, and we want to make that as rich as possible, both for those customers as well as for downstream algorithms that may use it for, say, search or recommendation. So many of you may have heard of some of these custom vision services that have arose. There's one from Google called AutoML Vision. They also have other services such as natural language processing. That's currently in beta. We've been working with them under their alpha program for several months. Another one is Clarify. So they've been around for several years, and they have offered a sort of a trusted tester program with us so that we can upload large sets of data and inform on how some of the performance is on public data sets. The third is Salesforce Einstein Vision. So that's part of the Salesforce package that provides this back-end AI capability. And then there's Microsoft Azure Custom Vision, which is in preview right now. And finally, there's also IBM Watson Visual Recognition. That one's grayed out. We didn't actually have the opportunity to evaluate that. It ended up being roughly 20 times more expensive than the other 4, so we stuck with those 4. What's interesting is the 2 on the left are more standalone products. You use them, you upload your data, you hit train, you get an evaluation with confusion matrices, and you get an API that services, deploys your model, and you can predict on it. The second 2 also do as well, but they're also integrated into their sort of ecosystem. So you can build something, if your organization uses Salesforce, you can build something that's on the back end that is being used by some of your customer-facing services, and similar to the Microsoft Azure platform. So for data sets, we spanned across 4 different data sets, 3 of them being public benchmarks, MNIST, Fashion MNIST, which was developed by Zalando as a more recent surrogate to MNIST, CFAR10, which expands to various different objects on the bottom left, and a small data set that we generated just to show sort of relevance in the e-commerce or retail domain. For each one of these, we did use the full data sets for the majority of our experiments. So that's on the order of several thousands of examples per class, and usually around 10,000 to predict against or evaluate your final performance. We also used a minimal data set, which was all these services. One of the things they really showcase is or have in their material is the ability to generalize on very small number of samples for your data set. That way you don't have to label as many as a consumer, and you just upload, I believe most of them are a minimum of 100 samples per class that you're trying to predict. And then finally, our data set here on the bottom left, this is one that we basically pulled from our databases and used a mix of what the database mentioned the attributes were, as well as some human labeled. And we isolated it to one single attribute. So in this case, it's dress print. Floral, not dress, which is something that's obviously not a dress, usually shoes or something else, as well as some ambiguous ones, like a long shirt that may appear to be a dress to somebody to an algorithm, so as an example. Solid color and stripes. We fed the full image that may actually include other products in it, rather than cropping it ahead of time. It also includes the models and sometimes more detailed backgrounds that show up. I should also mention that we didn't do too much pre-processing intentionally because the target customer for this service is people without that machine learning experience. So it's software developers or analysts or anybody who just has access to data and wants to push it up and see how it performs. So I figured it's about time for a wall of numbers. I didn't see too many this morning, so we can just go through some of this. I should mention this is really just for reference right here. I'm going to so when these actually get dispersed to everybody, you'll see a bunch of footnotes. Feel free to go through those and email me with any questions. What I'll do is just cover some of the highlights on the summary here. So on the It's actually a typo on the top left. This is classification accuracy. Each row is the service, and each one of the columns is the data set that was used, as well as the minimal data set and using the full data set for training. In terms of some takeaways that we've identified, in general, when you do have access to the full data set, AutoML using 1 hour of training does outperform the others. An unconfirmed hypothesis, at least in mine, is that Google AutoML uses a neural architecture search. They published something called NASNet, I believe, last year or the year prior. Some of this is based on. Whereas some of the other services train much more quickly. They'll train in less than 5 minutes versus up to a hour for AutoML. So it's more likely to be more of a transfer learning type of approach with the others, which is much quicker to train. On the other end, Microsoft Azure did underperform, but only slightly across the board. So if you factor in a number of samples you're testing against, a lot of these actually fall within sort of a standard margin of error. So performance itself, if you're not looking for the most precise model possible, you can likely get by with many of these solutions, which means performance really may not be the differentiator for this type of service for the target customer. That's speaking to the services. We also evaluated on a custom solution, or various custom solutions. One is a basic convolutional neural network. That's something that's like a 3-layer with some dropout, rectified linear units, something you would find in the examples directory of like a Keras or PyTorch or TensorFlow. The second is transfer learning approach. That's just doing it offline using a ResNet 50 architecture pre-trained on ImageNet and then fine-tuned. And then the final is the public benchmark, essentially the best we can find out in the wild performing against those. With this set, the public benchmark, of course, does outperform all those very significantly because it's trained specifically for that data set. But the transfer learning actually doesn't do too bad in many of the cases relative to the services as well. So if you are familiar with using some of those services, then you can get by with that. However, I'm going to speak to the other part of this, which is usability. So aside from the performance, there's many other dimensions one may consider as a target customer for this type of service. For example, there's cost, human labeling, user interface, so that's how well you can interact with it. Deployments, is it something you can actually use as a service? Is it integrated with additional platforms that company may offer? How quickly can you go from your data set to a trained model? Does it provide the ability, data audit does it provide the ability to interact with your data and understand where things may be erroneous? A feedback loop, so can you find some of those erroneous images that were classified and correct it and allow it to retrain? The overall API, so how you actually interact with it programmatically, transparency of the solution that you're working with, overall support, and can you sort of export it to a mobile platform? This is sort of colorized just based on our subjective experience, looking at it both from the lens of a target customer, for which we had interns that didn't have the machine learning experience, as well as people that do have some machine learning background. Red being either it is not a capability or we didn't find it adequate, yellow being not bad, and green being we kind of enjoyed it. I'll highlight a couple that we kind of really focused in on. One is cost, say per 10K, that's per 10,000 predictions, the ballpark cost of that. Many of these services also offer a free tier, which could get many people by with just like a quick check and playing around with it. The other one that we thought was very important was the API. It does come with most of them will come with a standard RESTful API that you can interact with. But for example, Clarifai had Python bindings that made it really quick to come to a solution and really easy to interact with. With that said, Clarifai does have a lot of the green marks. They are the most mature one out of here, so that they have a lot more capability. And the last one, which we found was important, was time to results. So for us, rapid prototyping is very important. So we wanted to make sure we were up and running as quick as possible. So now looking at those two viewpoints from the perspective of a data science or researcher, it's very useful in terms of benchmarking. So it gives you dynamically adjusting thresholds, and it gives you a quick look at precision, recall, AUC, classification score, and confusion matrices. So for us, it's helpful to just kind of do a quick sanity check. If we were to use something straight out of the box, you don't have to worry about improperly indexing inside a notebook or anything like that. You just upload it, and you at least get a rough order of magnitude of how you think something simple could work out. Human labeling was pretty convenient from an AutoML standpoint. They have the capability of, in the package itself, doing the labeling. So from a workflow perspective, that's very, very helpful so that it's already in there and you don't have to go through an external service. The last one is rapid audit and visualization. We actually identified many products in our backend database. For example, this is a solid color dress, but in our database it was marked as stripes. So this service allows you to identify where some of those major errors are in terms of false negatives, false positives, and adjust accordingly, and then retrain. So from a target audience perspective, i.e. the developers and analysts out there without the background, we identified a couple interesting scenarios that may end up as pitfalls for using this type of service. So it could be helpful to have a form of pre-processing assistance or explainability in the model and what it's actually using to make the predictions it's making. In this example, we fed it the entire image of this woman wearing a hat as well as the stripes. So there are actually two products in there. The model doesn't necessarily know that. We noticed it kept coming back as solid color. So what we did was just manually crop that image to different regions and fed that in as a prediction just to experiment. And we realized that it was really homing in on the hat as a solid color, even though it's trying to classify the dress. So when you isolate to just the dress, it worked fine. So that's something that if you still need some of that domain knowledge or an understanding of your product or your images to really get the best use out of the service. The other is some services offer additional training hours to improve the model, but you don't really know where the knee in that curve is until you continually train and hit diminishing returns, which could be somewhat tedious and expensive depending on how you're using it. So in our example, we had a 1-hour train that got an average precision 0.981 and a 24-hour train that was essentially the same thing. That's for our data set. Many other data sets may actually do well on that 24 hours. Similarly, we noticed that the type of additional data, a lot of them say, give it more data, it'll do better. It's not always the case. We had this example of this dress. So it's one dress with 4 different product images. For all of our products, we uploaded 4 images for that product, fed it in there, labeled, and said go. The service itself decided to do its cross-validation splitting. It split 3 of them into the train and left 1 out in the predict. And when we looked at this example here, when we go to predict on that dress for dress length in this example, it said it was a midi dress with high accuracy, which was accurate. But if you look at the dress, there's no way you can tell what the length is of that particular dress. So this is a case where there was sort of data leakage that the model or service didn't really know about, but the user has to have some knowledge that it's getting information in its training set that it's inferring out of its prediction item that's not actually inherent in the item. It's detecting essentially the pattern and the model, perhaps the background, and associating that with the label, which happens to be MIDI. So to conclude, these services, most of them just came out in the past year or two. Most of them are in preview or beta. It's really progressing along. They're trying to democratize AI, so to speak, to a lot of the users without the background. And it's getting there, but there are sort of pitfalls that as a user you need to make sure you're factoring in, or as a developer for these services need to keep in mind that there's going to be cases where you need to sort of adjust, pre-process, localize, and so on. From a data scientist standpoint, it serves as a really good sort of sanity check, rough order of magnitude and performance. And from the democratized standpoint, you just need to do additional inspection as a user as you use these products. We do have a lot more details on this, as well as how to use the service. The URBN engineering blog should be up in about a month with source code to follow with some of this information. In the meantime, if you have any questions, feel free to email and I can pass out details. Thank you.
many questions we've got? Who wants to go first? Yes, go again. Thank God you're in the audience.
No. Yeah? Yeah. You mentioned that you included some attributes that were more kind of subjective. Did you evaluate the performances on these particular attributes, or did you do some global statistics only?
Yeah, so just as a general measure, we ran both sort of manual models as well as using some of these services. For all of the services, we only did dress print, just because we wanted something that was concrete that we can look at. Even that, there's a lot of ambiguity, because you can have a floral dress with some stripes, or a pleat that may look stripes, and so on. Offline, we tried essentially that whole attribute set, and some of them, like dress sleeve length, is like 99+%, as long as you have the arm in the picture. It's very concrete. The ones that are more subjective, like lifestyle and even color sometimes, because of the mixture, those end up being closer to like a 70%-ish on these initial models. So that requires a little more work and sort of specific to those, getting a cleaner data set, as well as a better description of those products. So just the image itself often isn't enough. We're trying to factor in some of the product text that the copy people kind of bring in as well. Okay.
Okay, next questions. Gentleman down there. Again, the same guys asking the same questions.
Hi there. There's a lot being written at the minute about the combination of serverless computing, like AWS Lambda or Azure Functions or something like that, being combined with machine learning, and that being the driver for the next decade of software architecture. So, two-part question: A, do you believe that? And B, if you did you think about that whenever you were doing your comparison? You know, the wider services provided by those cloud providers.
Yeah, so I didn't mention a distinction between a couple of the different services. So there's sort of the deployment services that make getting any type of machine learning model up and scaled. There's standard machine learning services, like just a vision service that most of those services offer, where if you're trying to detect animals or people or logos, they already have pre-trained models and those work. And then there's sort of these custom models. These custom models essentially wrap everything in a somewhat intentionally opaque manner, where they give you a prediction API and that's it once you use it. Some of the other ones, the serverless architectures or those deployment architectures, they allow you the flexibility to put in any type of model. So if it's not just an attribute model, if you're trying to create a recommender or search engine or whatever you name, you can wrap that up and deploy that. We actually have a separate initiative right now that's trying to sort of identify the most appropriate service for deployment in sort of like a Kubernetes and Dockerized container environment for our that works well with the way our brands are operating their infrastructure right now. And that one's sort of in progress right now, so I can't speak to which ones we've sort of experimented with or enjoyed. But happy to talk offline more.
Okay, final questions, guys. Any more questions? Well, I'll ask Tom one then. Tom, I suppose the key question, which one are you going to carry on using?
I knew I was going to get that one. So right now we actually put the attribution effort a little bit on a back burner, actually, to focus more on some deployment efforts that I was just mentioning. For our purposes, we likely are going to be using at least one of those services for experimentation purposes, more on like a pay-per-use. Again, just to get some of the rough order of magnitude performance and the interactive environment, being able to quickly look at your data, partition off where the errors are, and relabel pretty rapidly. But as of right now, our organization doesn't plan on fully deploying with any of those at scale.
Well, okay. Well, hopefully, actually, what will happen is that all five will see this, and they'll all basically come and see you and offer you the technology for free and lots of support to make sure they rank the best. So, can I say thank you so much for Tom?
Thank you.